Hi everyone, it's Mrs. Griffin with the Unit 6 video for lessons 1 and 3. We're going to put them together and do some operations with radicals, which are also known as square roots. We're going to be doing square root radicals specifically. So in order to do that, simplifying them and multiplying them, we're going to need to remember what our perfect squares are. And remember, perfect squares are numbers that are created by squaring another number. They are also ones that can be square rooted perfectly. So for example, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared, 6 squared, etc. And we have 8 squared, 9 squared. And we have a whole bunch of them between 1 and 225. And those are the most commonly used ones. But there are also ones that continue higher than that. And other ones that could come up are, for example, 400, because that's 20 squared, and 900 is 30 squared, for example. So to square root a radical, the first thing we're going to do to simplify is to separate it into two factors, two square roots. The first one being the largest perfect square that goes into the number we're trying to simplify, and the second one being the non-perfect square that multiplies with it. And then once we have those, we're going to square root the first, which is the one that actually works because it's a perfect square, and keep the second, which is the non-perfect square. So if I'm doing 32, I have to think about the list of numbers up here and ask myself what's the largest one of these that goes into 32 evenly. And the answer is 16. It goes into 32 twice. And then what we're going to do is square root this 16 here. The square root of 16 is 4. And then we'll bring down radical 2 because that does not simplify. Also keep in mind that square roots and squares are inverses. So if we have any base squared and then we square root it, they cancel one another out and you're just left with the number inside. Okay? And if you have a number other than 2 in your exponent, what's going to happen is you're asking yourself what times itself makes 5 to the 10th. And remember that when you are multiplying, you would add these exponents. And so 5 to the 5th is how you would multiply by yourself to get 5 to the 10th. So in order to answer the square root of 5 to the 10th, the shortcut is to take your base, keep it, and cut your exponent in half. Okay, on to this one. If we have this number in front, it's going to come down with us because it's a coefficient. And we're going to say what's the largest perfect square from the list above that goes into 216 evenly. And 36 is the largest one. It goes into 216 6 times. And then we can square root this 36. The square root of 36 is 6. And the coefficients coming down, remember that that's multiplication anytime something is stuck to something else. And we'll bring down our radical. And then we'll multiply. 1 times 6 is 6, divided by 6 is 1, and 1 radical 6 is the same as just writing radical 6. Same thing with the coefficient here, bringing it down. The largest perfect square that goes into 300 is 100, and it goes in 3 times. We will square root that 100 to get 10, and then 2 times 10 is 20, so we would have 20 radical 3. And here's another one. The largest perfect square that goes into 18 is 9. It goes in twice. The square root of 9 is 3. And then we would multiply here and get 6 radical 2. Okay. Number 17, we have a rectangle. Its dimensions, meaning its length and width, are 5 and 10. And we want to find the length of the diagonal in simplest radical form. So now we're bringing in some of the things that we did back in Unit 1, because this is a right triangle now and we are looking for its hypotenuse. So we are going to use the Pythagorean theorem to do this. So we have our 5 and our 10 as A and B. And when you do 5 squared plus 10 squared, you're going to have 25 plus 100. Which you could do in one step and get 125, and then we would square root it. And up until now we've been leaving it that way, but we are now going to be doing our answers in simplest radical form, so we need to simplify this. So the largest perfect square that goes into 125, the largest number from the list, is 25, and it goes in 5 times, and then we would square root the 25 here and get 5 radical 5 for our hypotenuse, which is our diagonal. And this does have a unit, centimeters, so we should put that into our answer. Number 8, if one side of a square is 12 inches, well, it is a square, so they all are 12 inches. And another one where we're going to find the length of the diagonal in simplest radical form. So this is another Pythagorean theorem question. So 12 squared plus 12 squared is c squared, because again, we are looking for the hypotenuse. And so we have 144 plus 144, which is 288. And then when we square root it, we will simplify this radical. The largest perfect square that goes into 288 is 144, and it goes in twice. And so we would get 12 radical 2, and this is in inches. And then finally for number 9, the perimeter is 8 feet. Remember, perimeter is all of the sides added up, and if this is a square, that means we're just going to divide it and find that each side then would be 2 feet. And if we're looking for our diagonal, now just like the others, we can do Pythagorean theorem. So 2 squared plus 2 squared equals c squared, and 2 squared plus 2 squared ends up being 8. And then we can simplify. The largest perfect square that goes into 8 is 4, and it goes in twice. The square root of 4 is 2, radical 2 feet. Okay, now if we're multiplying two radicals, first thing we're going to do is multiply the coefficients, the outside numbers. The second thing we're going to do is multiply the radicands, the inside numbers, and create one radical. And then we'll simplify that radical. So for number 10, we'll multiply the outside numbers. 7 times 2 is 14. Multiply the inside numbers, which would be 96. And then we're going to sit there and figure out the largest perfect square that goes into 96. And if you want, you can go down that perfect square list in order. Check. 96 divided by 81 doesn't work evenly. 96 divided by 64 doesn't work evenly. Divide it by 49 and keep going down, dividing 96 by each one of these until you get one that works. And that's how you can do this. 16 goes into 96 6 times. So then square root this one, and that would be 4. And 14 times 4 is 56. So this is 56 radical 6. If there's no number in front, that's really a 1. 1 times 1 is itself, 1. And then we have our 20 here. So now we're going to simplify. The largest perfect square that goes into 20 is that 4 from up here. And so we get 2 radical 5. For this one, 1/3 times negative 5, multiply the top. And 18 times 3 is 54. And then we're going to simplify. So again, if you're not sure what the largest perfect square that goes into 54 is, divide 54 by each one of the perfect square numbers downward, starting with the top and working lower until you get one that works evenly. 9 goes in 6 times. The square root of 9 is 3. And then negative 5 times 3 is negative 15, divided by 3 is negative 5. And so we have negative 5 radical 6. 2 times 1/4 is 2/4, which is the same as 1/2. 8 times 3 is 24, which simplifies. The largest perfect square is 4, goes in 6 times. And the square root of 4 is 2. And 1/2 of 2 is just 1 radical 6, or just radical 6. 5 times 2, outer numbers, is 10. 7 times 14 is 98. We're looking for the largest perfect square that goes into 98. Again, you can divide by your perfect squares if you need to. 49 goes into 98 twice. And the square root of 49 is 7. So this becomes 70 radical 2. 2/5 times 5. 2 times 5 is 10. Divided by 5 is just 2. 12 times 28 is 336. And again, divide. 336 divided by 100, 81, 64, until you find one that works evenly. And the largest one is 16, goes in 21 times. 2 times 16 is 4, and then this just becomes 8 radical 21. Okay, number 16, if the length of the rectangle is radical 3 and the width is radical 6, find the area. Remember that that is just length times width. So radical 3 times radical 6 is radical 18, and then we'll simplify it. The largest perfect square that goes into 18 is 9, and it goes in twice, making this 3 radical 2. For number 17, the base of the triangle is radical 6, and the height, which would be on the altitude, is radical 18. Find the area. In a triangle, it's 1/2 of length times width. So we would be doing this, keeping the 1/2 in front. 6 times 18 is 108. And then divide until you find a perfect square that goes into 108. 36 goes in 3 times. And so that would become 1/2 of 6 radical 3, and 1/2 times 6 is 3 radical 3. Okay, so we're going to go on to lesson 3 and do those problems as well, adding and subtracting radicals. You can do the opening exercise on your own. Now to add or subtract, just like polynomials, you can only do this with like terms, so they have to have the same radical. So first you're going to want to simplify each individual radical, and then you'll be able to combine the coefficients of the like terms, and only the like terms. So when we do this, the first thing we're going to do is simplify each one, because a radical 50 and a radical 32 are not like terms. So the largest perfect square that goes into 50 is 25, and it goes in twice, making this 5 radical 2. And then we will simplify the 32. And the largest perfect square that goes into 32 is 16, also goes in twice. So this becomes 3 times 4 radical 2, because the square root of 16 is 4, which is 12 when you multiply by the coefficient of 3. And then we can combine our like terms. So 5 radical 2's plus 12 radical 2's is 17 radical 2's. Number 2 is going to work the same way. The largest perfect square that goes into 125 is 25, and it goes in 5 times. The square root of 25 is 5, and 1/5 times 5 is just 1. So this is 1 radical 5. And then for the 80, the largest perfect square that goes into 80 is 16, and it goes in 5 times. So this becomes 6 times 4 radical 5, which is 24. And then 1 radical 5 minus 24 radical 5's becomes negative 23 radical 5's. Going on to number 3, same idea, we just have 3 of them. So the largest perfect square that goes into 98 would be 49, and it goes in twice, making this 7 radical 2. Keep the 1/3 coefficient. The largest perfect square that goes into 27 is 9, and it goes in 3 times. So then we have to square root the 9 to get 3. And then 1/3 times 3 is just 1. Bring the rest all down. And then we have the last term. Now there's 3 of them. The largest perfect square that goes into 162, if you start dividing down, you'll see it's 81, and it goes in twice. So the square root of 81 is 9, and you only do the square rooting 1 time. You square rooted the 81 and got 9. So there's no more square root on the 9. You're stopping with that point, and you're just going to multiply. So the square root of 30, so 4 times 9 is 36, and then the radical 2 would come down. And then only the like terms can get added. So we have our 1 radical 3, and 7 and negative 36 makes negative 29 radical 2. And that could be written in either order. And the 1 does not have to be in front of the 3. Okay, don't worry if there's a decimal in front. That's not going to change anything. We already have like terms here. They both have a radical 2 on them, so we could just add. So 8.3 plus 7.9 is 16.2. Keep your radical, and you're done with that one. Okay, if you look at number 5, neither of these is a like term, and neither of them can be simplified. So this is the answer. These cannot be simplified any further. So there is no further answer than that. On number 6, the radical 5 cannot be simplified, but the radical 45 can. The largest perfect square that goes into 45 is 9, and it goes in 5 times. The square root of 9 is 3. And if I bring everything else down, then I can add. So negative 15 plus 3 becomes negative 12, and then keep the radical 5. Same thing here, we have 2 with a radical 7, 11 minus 6 is 5 radical 7, and then the 3 radical 2, it does not have a like term, so it can't be added, and we cannot simplify it any further than that. Okay, the radical 2 cannot be simplified any further. There are no perfect squares that go into it other than 1, and that's not going to be used. But the 8 can. 4 goes into it twice, and so the square root of 4 becomes 2. And then when we multiply the coefficient times 2, we're going to get 4. And then 19 radical 2's plus 4 radical 2's is 23 radical 2's. To find the perimeter, we're adding all our terms. So if you're just looking at these, they're already all radical 2's. So all you have to do is add them together, and you would get 6.5 radical 2. Okay, for these we are adding, but we do have to simplify. So the radical 12 would be radical 4 and 3, and the 75 would be radical 25 and radical 3. And when you add, you get 11 radical 3. For the last one, we would simplify, but doing that's not going to get us any more like terms than this. So we are done. And I will see you in class.